Okay, college algebra. Here we are talking about the fundamentals of just really algebra. It starts with sets of numbers. The natural numbers are 1, 2, and 3, so on and so forth. They're numbers that we use for counting purposes. All people seem to know them. Animals seem to understand 1, 2, and 3. We give it that letter N with a line on the side. Whole numbers are the same. They just include 0. So that's the difference. Whole numbers include 0. So write it like that. 1, 0, 1, 2, dot, 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 so on. E with a double line there. Expressed as a fraction. For example, 7/4 can be expressed as a fraction. The number 5 can be expressed as a fraction. It is 10 over 2, so it's also rational. Number 0 can be expressed as a fraction because it is 0 over 8. The number 0.3 repeating is rational because it could be expressed as 1/3. Rational is a Q with a double line there. Rational would be numbers like, say, the square root of 2 or pi. The letter E, maybe you've learned about that before, 2.718. These are examples of irrational numbers, and so they are not these things. The set of real numbers we talk about like that. These all comprise the real numbers. There are then what we call imaginary, and the imaginary numbers include numbers like, say, 4i or negative 3i. And all together they make up what we call the complex number system. And we're going to get to complex and imaginary later on, but right now these are real numbers. We're going to just look at different ways of writing sets of numbers. We have 3 to 5, so as we write it as an inequality, it would be 3 is less than or equal to x, which is less than or equal to 5. Because you have the brackets, we use the equal sign. If you were to graph it, it would just be 3 and 5, close circle, arrow between. If you look at an example like this one, you have x is greater than negative 2. Now, a lot of people struggle with how to write as an inequality. So start with the graph. Plot that negative 2. Whoop, I'm sorry, that's wrong. I don't know why I did that anyway. But if you plot 2 and you plot 0, you can see you have an open circle on negative 2. You have a closed circle on 0, and you join these two together. So negative 2 is less than x, which is less than or equal to 0. Okay? We'll try this one right here. Again, we know that it's challenging to sometimes write the inequality. So start with the graph. Plot 5, open circle on the 5, arrow goes back to this direction. And that would be x is less than 5. We won't do that one. It gives you an idea there as to how we write those inequalities in those sets. So we'll do a couple of these. We'll do A and we'll do C. Negative 3, we're going to write it as an inequality and then graph it as well, or interval and then graph it. We've got negative 3 and 9. Open circle on 3, close circle on 9. We draw them together. And as we write that as an interval, we would say negative 3 with a bracket because we have an open circle. And then 9 bracket because we have a closed circle. We'll skip B and D, but for letter C, we plot negative 4, a closed circle, arrow going that way. So that would be from negative infinity, can never put a bracket on infinity, and that goes to negative 4, and we bracket that guy. Okay? All right. Sometimes we have sets and we draw them together. So this is a union. This is an intersect. So this means A combined with B. So if you take the set of negative 2 to 6 and combine it with B, what's the resulting set? Well, let's think about it here. Okay, we've got negative 2, we've got 6, open circle, and closed circle. Okay, and we've got 0 to infinity. So 0 would be right here, closed circle, and to infinity. So if we combine those, if we take everything that's in that, it looks like we're going to go from negative 2 to infinity. That's the combination of those two. So that's what union means. We combine those pieces. This means we look for the intersect between the two. So let's look at A intersect B. If you look at this example, where is it that the red and the blue intersect or overlap? and that would be in that space right there. And so we write 0 to 6. So you can see the difference between the union and the intersect. The union and the intersect. We'll try two more. We'll do B and C. So if I draw out a graph, I think writing a graph is the most helpful piece. B is from 0 to infinity, closed circle. And then C is from -6 to 1. -6 and 1. And we are brackets there. The question is, if we union them together, what would we get? So that means everything combined together, we would be -6 to infinity. But if we talk about the intersection, the only overlap is from 0 to 1. And so that's a little bit of that information. That will help you get started on that first assignment. As you continue to work through that assignment, we go to exponents and radicals. Okay, just some things we have to do from memory here. 4 to the third is not 4 times 3, it's 4 times 4 times 4, which is 64. -2 to the fifth, this is 2 times 2 times 2 times 2 times 2, which is 32. And then you apply the negative. Okay? So just understand if there's parentheses around it, now it's -3 times -3 times -3. That is -27. So it does matter in some situations. For example, if you have -5 squared and -5 squared, this answer is 25. This answer is -25. So if it's parentheses, you're squaring the negative. If there is no parentheses, you're not squaring the negative. 11 to 0, anything to 0 is 1. Square root of 144 is 12. Some people may say -12. When we talk about square root, we're talking about the principal root. It would be different if it said x squared is equal to 144. And in that situation, you know you're looking for two solutions, so we would say plus or minus 12. This is simply asking for one result. The cubed root of -125 is -5. You can take the cubed roots of negatives. The fourth root of 81 is 3. And now we get a little bit more complicated. 2 cubed times 3 to the -2. That'll be 2 to the third times 1 over 3 squared. Or 8 times 1 over 9. So that would be 8/9. So if you have a negative exponent, drop it to the denominator. 1/3 to the third, that would be 1 over 27 times 6 squared is 36 over 1. 36 over 27. What are both of those divisible by? Very good. 9 is the correct answer. 4 over 3 is your result. Letter J, you're multiplying two radicals together. You could go ahead and take 5 times 45, but a lot of people don't know what that is. And so I'm going to do a little trick here. I'm going to do square root of 5 times square root of 5 times the square root of 9. Because the square root of 5 times the square root of 9 is 45. Now watch how easy this is. The square root of 5 times square root of 5 is 5, and the square root of 9 is 3. So I get 15. Now it does turn out if you multiply, you get square root of 225, which is 15. But it is nice to use the property of radicals in many situations to make life a little bit easier. Watch this again. Square root of 3, square root of 3, square root of 16. Because square root of 3 times square root of 16 is square root of 48. Well, square root of 3 times square root of 3 is 3, and then square root of 16 is 4, and I get 12. One more result, 2 to the -3 divided by 4 to the -2. What would you do first to simplify that? And in fact, we're going to move that to the top and that to the bottom. And so, because you have the negative, so it's 4 squared over 2 to the third, and you get 16 over 8, which is 2. As we continue along, we get to a little bit more complicated radical and exponent problems. If you're going to subtract radicals, you must make sure that the radicand is the same. So we reduce this to the square root of 2 times square root of 9 minus the square root of 2 times the square root of 100. The square root of 9 is 3, so I have 3 roots of 2. And the square root of 10 is square root of 100 is 10, so 10 roots of 2. So we have 3 roots of 2 minus 10 roots of 2, which is -7 roots of 2. This one is different because it says perfect cubes. Now, while I know the perfect squares are 1, 4, 9, 16, 25, so on and so forth, perfect cubes are 1, 8, 27, 64, 125, so on and so forth. So we're looking for a perfect cube that divides evenly into 16, and that would be 8, and it's 8 times 2. Now we're looking for a perfect cube that divides evenly into 250, and that is 125. Goes in twice. So you can see that the cubed root of 8 gives me 2 cubed roots of 2. And the cubed root of 125 is 5, so I get 10 cubed roots of 2. 2 cubed roots of 2 plus 10 cubed roots of 2 is 12 cubed roots of 2. Yep, a little tricky. Next one should be easy peasy. 3 times 4 is 12, and y to the 7th. When you have common bases, you multiply, you add the exponents. If you have negative exponents, bring them to where they are not. So bring the a's to the bottom, bring this b to the bottom, and that b to the top. And if you do that, you can see in the bottom you get a to the 5th, a to the 8th, and b to the 3rd. And at the top, you get b to the 7th. Now that you've switched them, go ahead and combine the terms that can be brought together. A to the 5th times a to the 8th can be simplified to a to the 13th. And then b to the 7th over b to the 3rd is b to the 4th. And because there's more on the top, it stays in the top. How about letter E? Did you know that this is the same as 3xy to the 4th? Some people actually take that 3 and they distribute it as though there's addition or subtraction on the inside. This one here, we can take 2 to the 3rd to get 8. And we have a power to a power you multiply, x to the 12th, y to the 9th. Now this problem becomes exactly like we saw before. 24, x to the 13th, y to the 13th. Letter F, when we have negative exponents, that creates a big problem. The first thing I like to do is change it to positive, and in order to do that, we have to move everything. 2x to the negative 3rd, y to the 4th on top, and x to the 3rd, y to the 3rd on the bottom. Used up that negative, so it's just squared. Now I'm going to use up the other negative by dropping this below. So I have 2y to the 4th over x cubed, y to the 3rd squared. So now we have 2y to the 4th over x to the 6th, y to the 3rd. Still squared. Some of you might like to take the y to the 4th over the y to the 3rd and get 2y over x to the 6th quantity squared. And now if we square it, 4y squared over x to the 12th. Those are some good examples. Sometimes we get fractions and then our brain goes to mush. So for example, in letter G, we have negative 2a to the 3/4 times 5a to the 3/2. Well, if it read negative 2a to the 3rd times 5a to the 5th, you would know what to do. You would go negative 10a to the 8th because you multiplied the negative 2 and the 5 and you added the 3 and the 5 to get 8. So do the same thing. You see, one great strategy in mathematics is if you come across a complicated problem, try an easier problem and see how it goes. So in this situation, we do have negative 10a to the, well, let's take 3/4 and add to it 3/2 or 6/4. And I get, in that situation, 9/4. And so that's my result. In this situation, we're raising to a power. So we'll do the first one, which is you know that when you take a power to a power, you multiply. So 8 times 3/2. Think about that, 8 times 3/2. So you do 8 divided by 2, which is 4, times 3 is 12. Or 8 times 3 is 24. Divided by 2 is 12. Either way, you get y to 12. The x, so we've got x to the 6. So 6 times 3 is 18. Divided by 2 is 9. But then it's 4 to the 3/2. What does that mean, 4 to the 3/2? Well, what that means is 4 to the 3rd, and you take the square root of it. So the 2 means the square root. So it'll be 64. Square root is 8. Yep, that's how that works out. So 8x to the 9th, y to the 12th. We'll skip I. No need. Doesn't really help. Last one, simplify the following algebraic expressions. We need to take out the perfect square. So it's a to the 4th, b to the 6th. Square root of that is a squared, b cubed. But when you did that, you just had the a to the 4th, b to the 6th. You were missing the b. So you have to leave that square root of b there, and we just have the square root of b. So take the perfect square that you can right away, and then go ahead and leave the rest over there. For example, perfect cube. What's the perfect cube that divides evenly into x to the 4th? It is x to the 3rd. That really doesn't look very good, does it? We'll go x to the 3rd. And then if you put an x to the 3rd there, you've got to put an x over there in order to make your x to the 4th. Now we have a y to the 6th and a y squared. The cube root of x to the 3rd is x. Cube root of y to the 6th is y squared. And then you have the square root of xy squared. Sometimes you just might want to multiply them together. Square root of w to the 6th, v to the 12th. What do you notice? Those are both perfect squares. We have w cubed, v to the 6th. There you have it. Nice intro to your first lesson. You can hopefully do that first worksheet.